The next topic is remainder and factor theorem. Let's get to the first question. We'll do the question and we'll understand the concept. Question number 1. Find the remainder when 2x cube minus 3x square minus 4x minus 5 is divided by 2x plus 1. Find the remainder when 2x cube minus 3x square minus 4x minus 5 is divided by 2x plus 1. Now you know that when you have to find remainder, you have done that in 8th class, you have to divide these two polynomials. So you divide the first polynomial by the second polynomial. This will be the dividend and this will be the divisor. You perform long division and then you find the quotient and the remainder. This thing you have done in class 8 in the chapter called Operations on Algebraic Expressions, and you did addition, subtraction, multiplication and division of algebraic expressions. So this is a classic case of division of algebraic expressions, but the only difference is we are not going to divide. We are going to apply remainder theorem. Remainder theorem is a theorem with which we can find the remainder when two polynomials are divided without actually performing the long division. So this chapter is all about finding remainder without performing long divisions of two polynomials. That is the whole concept. Okay, so let us find the let us understand the method for finding the remainder. Okay, so let f of x, now any polynomial or algebraic expression can be given a name. So the name which we will be giving to this polynomial will be f of x. F bracket x is known as f of x. F of x is equal to 2x cube minus 3x square minus 4x minus 5. This is f of x. Okay, and g of x is equal to 2x plus 1. This is the divisor. Okay, we have to find the remainder when f of x is divided by g of x. Okay, but we do not have to apply long division method. We have to apply remainder theorem. Okay, so you have to write these steps by remainder theorem. When f of x is divided by g of x, g of x is equal to 2x plus 1, then g of x is equal to 0. You have to first equate your divisor by 0. So when you equate divisor by 0, you will find value of x or a 0 of the polynomial. And that is 2x plus 1. That is 2x plus 1 is equal to 0, which means x is equal to minus 1 by 2. So you found 0 of the polynomial. 0 of the polynomial means the value of x. If you put this value of x in this polynomial, the answer will come out to be the remainder, right? So we have to put the value of x in the polynomial f of x. So what we have to do next is, therefore, remainder is equal to f of x, but what is x? Minus 1 by 2. So we will write minus 1 by 2. F of minus 1 by 2. This will be the remainder. So wherever there is x, we will put minus 1 by 2 in the expression f of x. So in this expression, wherever there is x, we will put minus 1 by 2. So 2 bracket minus 1 by 2 the whole cube minus 3 bracket minus 1 by 2 the whole square minus 4 bracket minus 1 by 2, and here will be minus 5. So this is 2x cube minus 3x square minus 4x minus 5. Let us solve this. Here we will get 2 into minus 1 by 8. Minus 1 cube is minus 1, 2 cube is 8, minus 3 into minus 1, sorry, it will be plus 1, because minus 1 square is plus 1, 2 square is 4, minus 4 into minus 1 by 2 minus 5. Okay, let's solve this. 2 1s are 2 4s are, so this will be minus 1 into 1 minus 1 upon 4 minus 3 into plus 1 is 3 upon 4. This will cut. This will be minus 1 into 2 minus 2, and this minus is there, so it will become plus 2, and this will be minus 5. Okay, let's take them together. Minus 1 minus 3 the whole upon 4 plus 2 minus 5 is minus 3. This will be minus 4 upon 4 minus 3. That will be minus 1 minus 3, and the answer will be minus 4. So again, if you pay attention, how did we do it? We knew that there are two polynomials, f of x and g of x. We had to find the remainder. So first we equated g of x, that is the divisor, by we equated with 0. We found the value of x, which is 0 of the polynomial. This value of x we substituted in f of x. Wherever there is x, we put the value of x, that is minus 1 by 2. When we put the values and we solve, we got one number. This is nothing but the remainder. So the remainder when this f of x is divided by g of x is minus 4. Without performing long division, we found the remainder. So this is the whole idea about the chapter, remainder and factor theorem. This is the only concept which you are going to apply in the whole chapter. There is nothing else. It is quite simple. The chapter is small and simple. When you will solve the example, you will come to know. But there are some questions which are tricky, so now I am going to directly go on to the tricky questions. Let's do the next one. Example number 2. So the polynomial p of x is kx cube plus 9x square plus 4x minus 8 when divided by the polynomial q of x, which is equal to x plus 3. So this is what? This is the dividend, and this is the divisor. This is divided by this. P of x is divided by q of x. It leaves the remainder 20. So what is given? Remainder. Remainder is 20. Leaves, I'm sorry, the remainder is minus 20. Remainder is minus 20. Find the value of k. If p of x is divided by q of x, the remainder comes out to be minus 20. What will be k? Okay, so first what do we do? We put q of x as 0. If q of x becomes 0, then x plus 3 becomes 0, which means x is equal to minus 3. Now we will put p of minus 3 and we will solve this equation. And we already know the remainder. So whenever we put in the place of our dividend, in the place of x, if we put the value of x, we get the remainder, and we already know the remainder. Remainder is minus 20. So what do we equate minus 20 with? We put this whole expression with the value of x, that is minus 3. So k into minus 3 cube plus 9 into minus 3 square plus 4 into minus 3 minus 8 gives you the remainder, that is minus 20. Now when you solve this equation, you directly get the value of k. Let's do it. Minus 3 cube is minus 27. So minus 27k plus minus 3 square is 9. 9 9s are 81. 4 into minus 3 is minus 12. Minus 8 is minus 20. Okay. Minus 27k. Okay. Here what do we have? Minus 12 minus 8 is minus 20. 81 minus 20 is plus 61. Let's shift 61 over there. Minus 27k is equal to minus 20 minus 61. Minus 27k is equal to minus 81. Minus minus gets cut. K is equal to 81 by 27, and the answer is 3. 27 3s are 81. So the value of k for which this polynomial divided by this polynomial gives you remainder minus 20 is 3. The value of k is 3. Okay, let's do a question where we have to factorize a given polynomial. Question number 3. So I will name the given polynomial as f of x, which is 3x cube plus 2x square minus 19x plus 6. So what you need to do, you need to use the remainder theorem and factorize the given polynomial completely. Okay, you have to factorize the given polynomial completely. So please pay attention over here. Here you see a cubic polynomial. This is example of a cubic polynomial. Why is it known as cubic polynomial? Because the degree of x, the highest power of x is 3. So whatever is the highest power of the given polynomial is known as degree of that given polynomial. This is a new term for you. You have not come across this term earlier. So please pay attention to this. The degree of this polynomial is 3, and that is why it is known as cubic polynomial. So understand that if you want to factorize this completely, you should already know how many factors will be there. If it has power 3 or degree 3, it will have 3 factors. Given polynomial, if it has degree 2, it will have 2 factors. So the degree and the number of factors are always equal. If the degree of the polynomial is 3, the factors also will be 3. So this polynomial will have 3 factors. Now we have to factorize it completely. We don't know any factor. Okay, we have not been given any factor. We have to factorize this. Now even if you apply the method of factorizations which you have learnt in class 9, chapter number 5, factorization, you cannot factorize this because it does not fit into any category. Remember what you have learnt in class 9. You have learnt a method of factorization where you have to take out common and factorize. Now here you cannot take out anything common and factorize. Grouping, taking out common does not work here. Splitting the middle term only works for quadratic polynomials, quadratic equations, but this is not quadratic, this is cubic. Quadratic means degree 2, this is degree 3, so you cannot use splitting the middle term. You cannot use a square minus b square, that is difference of 2 squares. You cannot use a plus b the whole cube. This is not in the form of a plus b cubes, a plus b the whole cubes expansion. That has a different form. So you cannot use those methods of factorizations which you have learned in class 9. So how to factorize this completely? Now for this you will use a method which is known as trial and error method. Listen to me very carefully. Trial and error method. So how do you use this trial and error method? First you will put some values of x in this particular equation and try to solve it. So the question arises, which values should you put in the place of x so that the answer of this polynomial becomes 0? Okay, so please understand that there are some values which you must try, that is plus minus 1, plus minus 2 and plus minus 3. Out of these 6 values, there are 6 values here, please pay attention: plus 1 minus 1, plus 2 minus 2, plus 3 minus 3. Out of these 6 values, at least one value will give you an answer 0. When you put that value in this equation, you will get the answer 0. So I'm going to do an oral calculation, and with that oral calculation, if you listen to me and if you do a rough work in your notebook right now, when you pause the video and do the rough work, you will understand that oral calculations will help you to get the 0 quickly. Okay, so first I'm going to put plus 1 in the place of x and see what the answer comes out to be. So if I put plus 1 here, 3 into 1 cube is 3, 2 into 1 square is 2, so 3 plus 2 is 5, 5 minus 19 into 1 is minus 19, so 5 minus 19 is minus 14, minus 14 plus 6, no, minus 14 plus 6 is not 0, so plus 1 is out of the question. Plus 1 is not 0 of the polynomial. Okay, we will try with minus 1. Okay, if we put minus 1 over here, 3 into minus 1 cube, 3 into minus 1 cube is 3 into minus 1, that is minus 3. 2 into minus 1 square, 2 into minus 1 square is 2 into 1, that is 2. Now here you've got minus 3, here you've got plus 2. Minus 3 plus 2 is minus 1. Okay, minus 1 plus 6, minus 1 plus 6 is plus 5, and here you get minus 19 into minus 1, which is plus 19, but you've got plus 5 here and plus 19 here, it does not give you 0, so minus 1 is also out of question. Please pay attention how I'm doing the calculations. I'm doing oral calculations here. If you want, you can do rough work by pausing the video. I'm just putting the values of plus 1, minus 1, plus 2, minus 2, plus 3, minus 3 in place of x in this equation. You can also do that one by one, but it is better to do orally. If you do orally and get the answer, you can directly find one factor. If you have one factor, you can find the other factors very easily. So factorization will become simple. Let us put plus 2 in the equation. Okay, plus 2 will give over here 3 into 2 cube. 2 cube is 8, 8 3s are 24. So I've got 24. I'll just write here, numbers are bigger. 2 into 2 square, 2 square is 4, 4 2s are 8, so plus 8, and we have got plus 6 over here, so just add them. 8 plus 6, 14, 14 plus 4 is 18, 18 plus 20 is 38. Okay, so I've got 38 over here, and here I'm going to put 2, so 19 2s are 38, so I've got minus 38 over here. So minus 38 and plus 38 will get cut and I will get 0. So yes, with plus 2 I am successfully able to get 0 as the value of this polynomial. That means plus 2, the value of x when taken as plus 2 gives you 0, that is 1 0 of the polynomial. So how to write this? So when x is equal to 2, f of 2 is equal to 3 into 2 cube plus 2 into 2 square minus 19 into 2 plus 6, which is 24 plus 8 minus 38 plus 6, which is 0. Right? So how do I wrote this directly? I did some oral calculations and then I got to know that when I put 2 in the place of x, I get the answer of this polynomial as 0. So you must understand that if you do orally and directly write the value of x, it is acceptable. Okay, you don't have to put all these values of x and then do your calculations, show the calculations. There is no need of that. If you do oral calculation and with one of the values of x, if you get the answer of f of x as 0, you can directly show that and continue with the solution. Okay, so always remember that these 6 values are very, very important, and out of these 6 values you will always get 1 or 2 zeros of the polynomial or 1 or 2 factors of the polynomial. Here we wanted just 1. Okay, so we will write, therefore x is equal to 2 is a 0 of f of x. Therefore x minus 2 is equal to 0, that is g of x is equal to x minus 2 is a factor of f of x. So what did I write? I wrote that since with x is equal to 2 I am getting 0 as the answer, so it is 0 of the polynomial f of x, and I took this 2 to the left hand side, so it became minus, and here I got 0, so x minus 2 is equal to 0, or g of x is equal to x minus 2 is a factor of f of x. So see, the question was factorize this completely, and this was a cubic polynomial. I told you in the beginning, cubic polynomial has highest degree of 3, so it has got 3 factors. I've already got one factor over here, x minus 2. Now how many factors I need to find now? 2. Only 2 more factors are needed to be found now. So let's go ahead and find 2 more factors. I've got one factor is x minus 2. Let's find 2 more factors. So for finding 2 more factors, a long division has to be done. You have applied remainder theorem and found one factor by substituting the value of x by trial and error method. You just assumed some values plus 1, minus 1, plus 2, minus 2, out of which plus 2 came out to be a 0 of the polynomial. But now you have applied remainder theorem. Now you have to, for finding 2 more factors, 2 more remaining factors, you have to do long division. So long division is part of the syllabus, but only in few of the questions, right? So let's do the long division. So we will write our divisor inside the box, that is 3x cube. I hope you remember how long division is done. I'm going to teach you again over here. Plus 2x square minus 19x plus 6. 3x cube plus 2x square minus 19x plus 6. This is our f of x, and our divisor, which came out to be x minus 2, right? That's one of the factor. Now if I divide this polynomial by its factor, definitely I'm going to get remainder as 0. Also I'm going to get a quotient over here, which will be one more factor, right? So let's find that quotient. So 3x cube divide by x. 3x cube divide by x is 3x square. 3x square into x is 3x cube. 3x square into minus 2 is minus 6x square. And draw a line over here. Subtraction. This is positive, it will become negative. This is negative, it will become positive, right? 3x cube minus 3x cube becomes 0. Plus 2x square plus 6x square becomes plus 8x square. Minus 19x comes down. Now plus 8x square divide by x. How much is plus 8x square divided by x? It is plus 8x. So write plus 8x over here. 8x divided by 8x plus 8x multiplied by x is plus 8x square, and plus 8x multiplied by minus 2 is minus 16x. So this will be minus, this will be plus, so 8x square minus 8x square becomes 0, minus 19x plus 16x becomes minus 3x, bigger number sign, plus minus minus, and plus 6 comes down. Now minus 3x divided by plus x gives you minus 3, and minus 3 into x is minus 3x, minus 3 into minus 2 is plus 6. Negative sign changes, minus 3x plus 3x gets cut, 6 minus 6 becomes 0. So this is the remainder. Okay, so when, please understand how it goes now. When f of x is divided by g of x, remainder is 0. Therefore, f of x is equal to g of x into q of x plus r of x. You know what is this? This is dividend is equal to divisor into quotient plus remainder. Remainder is 0 already, so we can write this dividend, that is 3x cube plus 2x square minus 19x plus 6 as product of g of x, that is divisor, x minus 2, and q of x. Remember how we got x minus 2? By trial and error method. How we got q of x, quotient? By long division, and it is 3x square plus 8x minus 3. So these are the two factors of this cubic polynomial. But remember what I told you in the beginning of this question. I told you that this cubic polynomial should have 3 factors because it has the highest degree of this cubic polynomial is 3. So it should have 3 factors. We are getting 2 factors, but please pay attention over here. This is a quadratic polynomial. Quadratic polynomial has a degree of 2. So you can further factorize this by splitting the middle term and resolve it into 2 more factors, right? So we are going to factorize this. To factorize this, you must remember splitting the middle term. I will show you again. 3 into minus 3 is minus 9. First we multiply the coefficient of x square with the constant term. Coefficient of x square is 3 and constant term is minus 3. 3 into minus 3 is minus 9. Now you need to find 2 factors of minus 9 such that their sum or their difference is the coefficient of the middle term, that is x, that is plus 8. Okay, so it's very easy. The factors of 9, you can't take 3 threes up because it will not give you 8 by adding or subtracting. Can you take 9 ones up? Yes, definitely you can take 9 ones up because those are the only factors by the addition or subtraction of which you get plus 8. Now you want plus 8, so 9 will be plus and 1 will be minus. 9 into minus 1 plus 9 into minus 1 is minus 9, plus 9 minus 1 is plus 8. So this fulfills the requirement of splitting the middle term. Let us split 3x square plus 9x minus x minus 3. So x minus 2, here you will get common 3x bracket, here x will be left inside, plus 3 will be left inside, here common will be minus 1, here x will be left inside, plus 3 will be left inside. I hope you know what is splitting the middle term, right? Okay, so x minus 2, 3x minus 1 and x plus 3. These are the 3 factors of your cubic polynomial f of x. This is how you do the whole question. Let's look at it again. First we did trial and error method where we found one factor of this cubic polynomial. by randomly putting some values of x into f of x, and when we got, with oral calculation, when we got the value of f of x as 0, that value was the 0 of polynomial, and from that 0 we made a factor which is x minus 2, and with that factor we divided our given polynomial. We got the remainder as 0. So whatever quotient was there was the second polynomial, which was in the form of second factor, which was in the form of quadratic polynomial, which was again factorized by the method of splitting the middle term, and then we found the 3 factors. So that is how you factorize a given polynomial, let it be cubic or biquadratic, completely without knowing even a single factor. Okay, so you have to use remainder theorem as well as long division in this kind of question. Okay, let us do one more question based on remainder theorem, then we will move to factor theorem. Okay, next question. When divided by x minus 3, the polynomials, okay, so there are 2 polynomials. Let us write the polynomials. P of x is equal to x cube minus px square plus x plus 6. This is one polynomial, and the other polynomial is q of x. I am giving these names to these polynomials so that it is easy to identify them. 2x cube minus x square minus p plus 3 bracket x minus 6. So these 2 polynomials, when divided by x minus 3, you have to divide both these polynomial by one of the polynomial x minus 3. So x minus 3 is your common divisor. Okay, I will write x minus 3 as g of x. That is your, in bracket I am writing, divisor. That's your divisor. So when these 2 polynomials are divided by this divisor, they leave the same remainder. The remainder is same. Okay, find the value of p. You have to find the value of p. Okay, so very interesting question. Easy also, but very interesting. Let's see how to find it. So first we will find the value of x, that is 0 of the polynomial. Okay, so let g of x is equal to 0. That means x minus 3 is equal to 0, which means x is equal to 3. So we found the value of x. By equating the divisor with 0, we first find the value of x. Now we put the value of x one by one in p of x and q of x, right? So whenever we put remainder 1, whenever we put the value of x in any of the polynomial, we will get the remainder. So remainder 1 is p of 3. What do you mean by p of 3? P of 3 means wherever there is x, you put 3 in place of x. So in first polynomial p of x, you put 3 in place of x. So 3 cube minus p into 3 square plus 3 plus 6. So 3 cube is 27 minus 9p plus 9. Okay, 27 plus 9 is 36 minus 9p. Okay, so that's what we have got by putting the value of 3 in the first polynomial. Now that's the first remainder. Remainder 2. Remainder 2 will be q of 3. The second polynomial is q. In the place of x in the second polynomial, we will put 3, q of x. So it will give you 2 into 3 cube minus 3 square minus p plus 3 into 3 minus 6. So that is 3 cube is 27, 27 twos are 54 minus 3 square 9. Okay, now you multiply this 3 with both of them, so it will become if 3 comes ahead, minus 3 into p is minus 3p, minus 3 into 3 is minus 9 and minus 6. So 54 minus 9 minus 9 minus 18 minus 18 minus 6 is minus 24 minus 3p, and that is 30 minus 3p. So this is the remainder, the second remainder. Now according to the question, when this divisor divides both the polynomial, remainder is same. Find the value of p. So remainder is same means we can equate the value of the remainder, and therefore 36 minus 9p is equal to 30 minus 3p. Let's take 9p over there. 36 minus 30 is equal to 9p minus 3p, right? 9p goes over here, becomes positive. 30 comes over here, becomes negative. 36 minus 30 is 6. 9p minus 3p becomes 6p. So p is equal to 6 by 6, and that is 1. So value of p is 1. So these kind of questions are also there in your exercise textbook, and they are also asked in boards. Okay, let's move to the next part, that is factor theorem. So the next part is factor theorem, remainder and factor theorem. First we did remainder theorem, then there is now factor theorem. But what is factor theorem? It is nothing different from remainder theorem. Only difference is in factor theorem, the given polynomial must be a factor of other polynomial. Whenever one polynomial is factor of second polynomial, if you divide them, what is the remainder which you will get? 0. Whenever one polynomial or one number is a factor of other number, if you divide them, you must get the remainder 0. So in this case also you will apply remainder theorem. The only thing is, if you get remainder as 0, then the one polynomial is factor of other, otherwise it is not. Right? So you have to apply remainder theorem only. But why is it known as factor theorem? Because in factor theorem we must get the remainder as 0 for one polynomial to be factor of the other polynomial. Okay, so that's the only difference. Let's do one question and we'll understand. Okay, find the value of k if x minus 2 is a factor of x cube plus 2x square minus kx plus 10. See, g of x is equal to x minus 2 and f of x is equal to x cube plus 2x square minus kx plus 10. Find the value of k. Find the value of k when x minus 2 is a factor of x cube plus 2x square minus kx plus 10. So it is given that g of x is a factor of f of x. Now if g of x is a factor of f of x, what is the remainder which you will get? What remainder will you get when you divide f of x by g of x? 0. So that's factor theorem, right? But they have already given that g of x is a factor of f of x, so we already know that remainder is going to be 0, right? We have to find the value of k. We already know that remainder is 0, therefore remainder is 0. We already know this. There is one more thing in the question which is asked, hence determine whether x plus 5 is also a factor. Okay, so is x plus 5 also a factor of f of x? That you have to find. Okay, first we will find the value of k and then we will see that x plus 5 is a factor or not. Let's find the value of k. So first thing, I know g of x. What will I do? I will equate g of x with 0, which implies x minus 2 is 0, which implies x is equal to 2. The value of x is 2. Now we will put the value of x in f of x. So f of 2 is equal to 2 cube plus 2 into 2 square minus k into 2 plus 10. Now whenever I put the value of x, what should I get? I should get the remainder. And what is the remainder? 0. So that is factor theorem. We already know that remainder is 0. 2 cube is 8 plus 2 square 4 2s are 8 minus 2k plus 10. 8 plus 8 16, 16 plus 10 26. So 26 minus 2k. I will shift 2k here. 2k is equal to 26. So k is equal to 26 by 2, that is 13. So the value of k for which f of x is a factor of g of x is 13. So I got the value of k. Now I can write the f of x all over again. F of x is equal to x cube plus 2x square minus 13x plus 10. This is the value of my f of x. X cube plus 2x square minus, in the place of k I put 13x plus 10. Now I have to find whether x plus 5 is a factor of f of x or not. Okay, so let us give this x plus 5 a name. Okay, I've used g of x, I've used f of x, let me use h of x. So h of x is equal to, let h of x is equal to x plus 5. Therefore x plus 5 is equal to 0, which implies x is equal to minus 5. So I'll put the value of minus 5 and check what is the remainder in f of x. So f of minus 5 is equal to minus 5 cube plus 2 into minus 5 square minus 13 into minus 5 plus 10. So here what will I get? Minus 125. Here I will get 25 2s are, that is 50. Here I will get plus 65 and here I will get plus 10. So minus 125, 50 plus 65 is 115 plus 10 125. So minus 125 plus 125 is 0. So what is the remainder? 0. So if the remainder comes out to be 0, then what you can say about the polynomial? This polynomial is a factor of given polynomial. Therefore x plus 5 is a factor of h of x. H of x, right? So that's one type of question which is there. Sorry, f of x, not h of x, f of x. Okay. Okay, let's do one difficult question. This is slightly difficult and lengthy question. So we can complete this chapter completely. The question is, find the values of P and Q. Find the values of P and Q if x plus 3 and x minus 4 are factors of x cube minus px square minus qx plus 24. Find the values of P and Q if x plus 3 and x minus 4 are the factors of x cube minus px square plus minus qx plus 24. Okay, so what we are going to do is, we know that these two are the factors. So we are going to put the values of x one by one in the given equation, and let's see what happens to the equation. Whatever happens to the equation, we'll come to know that how to find the values of P and Q. Let's find it. Let's name our equation. Okay, g of x is equal to x plus 3 and h of x is equal to x minus 4 are factors of f of x is equal to x cube minus px square minus qx plus 24. Right? So these two are factors of this given polynomial, and therefore let g of x is equal to 0. Therefore x plus 3 is equal to 0, which implies x is equal to minus 3. And let h of x is equal to 0. Therefore x minus 4 is equal to 0, which implies x is equal to 4. So we got two values of x. We will put these two values in the given equation f of x one by one. Therefore f of minus 3 is equal to x cube. So minus 3, wherever there is x, we have to put minus 3. Minus 3 cube minus p bracket minus 3 the whole square minus q bracket minus 3 plus 24. Now we put the value of minus 3 in the full complete equation of f of x, and we know that g of x is a factor of f of x. That means the remainder we know already, remainder will be 0. So minus 3 cube is minus 27, minus 3 square is 9, 9 into minus p is minus 9p, minus q into minus 3 is plus 3q plus 24, minus 27 plus 24 is minus 3, so minus 9p plus 3q, and this will be minus 3. Yes. Okay. Is there anything common? Let's take out common. I think minus 3 should come out common. Yes. And inside will be 3p minus q. Since minus sign has gone outside, this sign will change into minus, and this sign will change into plus. This minus 3 will get divided here and will become 0, and we will be left with 3p minus q plus 1. Okay, you can shift plus 1 over there, so you get 3p minus q is equal to minus 1. Now this is equation number 1. You got this equation when you put the value of x is equal to minus 3 in f of x, and you equated that remainder as 0 because x plus 3 is a factor of f of x. Let us do the same thing on the other side, that is for h of x, because that is also a factor of f of x. So we will put f of 4. So wherever there is x, we will put 4. So it will be 4 cube minus p into 4 square minus q into 4 plus 24. Since h of x is a factor of f of x, the remainder automatically becomes 0. 4 cube is 64. 4 square is 16 minus 16p minus 4q plus 24. Okay, 64 plus 24. 4 plus 4 8, 6 plus 2 8, so 88. So it will be minus 16p minus 4q plus 88. If you want, you can take out something common. 4 is common, let's take it out. So 4 becomes common and you get, let's take out minus 4 common, so this will become positive. So it will become minus 4p, sorry, plus 4p because minus has gone out. Minus 4 has gone out, so plus q. And if you take out 4 as a factor from 88, minus 4 as a factor, it will be minus 22. Minus 4 will go this side and become 0. So 0 is equal to 4p plus q minus 22 is equal to 0. And this 22 you can shift this side. So 4p plus q is equal to 4p plus q is equal to 22. This is equation number 2. So our two equations are 4p plus q is equal to 22 and 3p minus q is equal to minus 1. Perfect. Now we have to solve these two equations. Now do you remember in class 9 we have studied how to solve linear equations in two variable or simultaneous linear equations. Simultaneous linear equations are solved with the help of many methods. There is cross multiplication, there is substitution, there is elimination by equating the coefficients. So we will use the method of elimination by equating coefficients. So let us equate the coefficients of equation 1 and 2. Now there is one coefficient, there is one variable q whose coefficients are already same. The coefficient of q here is 1, here also is 1, and also their signs are opposite, plus and minus. So the process now becomes very easy. Adding equation 1 and 2, 3p minus q is equal to minus 1 and 4p plus q is equal to 22. If you add them, 3p plus 4p is 7p plus q minus q gets cancelled. 22 minus 1 is 21. So p is equal to 21 by 7, and that is 3. So the value of p you have got already. Putting p is equal to 3 in equation 1. So 3 into 3, 3p minus q, 3 into 3 minus q is equal to minus 1. So 9 minus q is equal to minus 1. That means 9 minus 1 comes here, plus 1 is equal to q, and therefore q is equal to 10. So p is equal to 3 and q is equal to 10 is the correct answer, and that's how you solve this kind of questions. So the chapter is over. There are some more complicated questions in the exercise you will find, but if you apply the same concept, they will also become easy. Please watch this video very carefully. If possible, you can watch it more than once. Try to understand the concept, try to understand the method. Please apply the same kind of method and use the same statements which I have been writing and elaborating the method. So if you do the same thing, same way, your marks will not cut, and you will get correct answer without making any mistakes whenever you solve it. Okay, so see you in the next video.